Happy Friday. Happy Friday. Hope your classes are going well. Hope things are going well. All right, let's take a look at some more. So we left off on Wednesday, and so I think the last thing I covered on that was we were looking at lists, and we got to basically subsetting a list. And I said you can subset and slice a list. This is, I think, where we left off on Wednesday. And you use kind of square brackets to slice up a list. And I don't know. That's how you kind of subset to do things. Okay. In Python, some of the objects are what we call mutable, and other objects are immutable. Lists are objects that are mutable. So that means the lists themselves change. And then, if you give another name to the list, then you have two names kind of pointing to the exact same object, okay? So here in memory, we are creating a list called fam, but this list contains things like the string Liz and these numbers, 1.73, the string Emma, etc., 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 okay? So this is going to be an object that exists in memory, all right? And then we're going to give this name fam, and fam is going to point to this object in memory. Okay, this line right here. Here, let me clear all of my outputs here. This line here, second, basically, is also going to just be a name that points to the same exact object. Okay, and then so what I'm doing here is in this line I'm saying change the zero index thing, the object or the item at index 0, change that to sister. Okay? And so when I do that, and I ask, hey, print second now, okay? Well, it's that first item is going to be now sister. And then if I say, hey, what is fam? Well, it's pointing to the exact same object, okay? So both of those things will have sister now in the index 0 position there, okay? Because here we established the list here with Liz, and then we changed the index 0 value to sister, and then both second and fam are pointing to that exact same list, okay? Meanwhile, in this code, I'm creating this list called fam, right? And then I'm creating a copy. Okay? So now I have another copy here. And this thing is going to be called second. So I've got two different objects now. Okay? I could also create a copy by doing fam.copy, but these are both ways to kind of take that existing list and copy it. And then so over here, I'm going to say change the index 0 value to sister. Okay. And then we're going to print this out. Print sister, so that will contain, or print second, so that will contain this thing. And then when I say print fam, it'll print this thing. Okay? So these things are going to have, when we print second, it will say sister. When we print fam again, it will still say Liz. So that's what we see here. Okay? Liz, sister, Liz. Okay. Here, if I say make another copy of fam, okay? Fam right now is Liz 1.73 Emma. We can print that out. That will be a copy of fam. We can change the index 1 and still there. So the index 1 value changes to 1.65. When we print fam back, it's still unchanged as what we had before. Okay, so in all of these things, fam is still this. If you call list, this is another way to make a copy. Okay, this is another way you can make a copy. You can take currently existing list, like fam, put it inside the function list. The function list basically just takes whatever you give it and puts it into a list. And so there we have, okay, so list 2, we've changed the index 1 value to 1.9. And so that's a copy. And so again, these two things are different objects. And so one changes to one doesn't affect the other. Okay, so these are all kind of copies of each other. I guess kind of the key thing I want to make sure everybody understands is that here, by having second equal fam, they're both pointing to the same object. So changing second is changing the same object as fam because it's the same object up in this code cell. Okay. Here's one thing that we can do is you can also assign. You can use assignment in conjunction with slicing. Okay. So here, if we look at what fam is right now Liz 1.73, Emma 1.68. If I slice fam to (1:3), that's going to slice out basically 1.73 in Emma. And basically I can take these values, 1.8 in Jenny, and then assign that into that slice there. Okay, so now we're going to get Liz, and then that 1.73 will be replaced with 1.8. The Emma will be replaced with Jenny, and then it will continue on 1.68 mom, and so on and so forth. So that's what we have there. Okay, so you can use slicing in conjunction with assignment, and that can be used to change values, which is just kind of neat. Okay, all right, we have a few methods, and these things can take existing lists and alter them or make copies of them. Basically do things with this. All right. So we have list.copy, and this is going to create a copy of the list. This is known as a shallow copy. Okay. It's equivalent to taking the list A and then doing square bracket colon in there with no other kind of values in front or after the colon. And then append takes the list and then it just adds something, appends it to the end of the list. And it's equivalent to just kind of saying A square bracket, the length of A, and then kind of appending that last value there. So here I've got this list fam, okay, and it ends with dad in 1.89. And then we're going to append, we're going to do fam.append quote me, okay, and then so the list fam itself has been modified, okay. So one thing I wrote here in the comments I wrote, unlike R, you don't have to kind of capture the result of the function. So a lot of times in R, anytime you wanted to make a change, you had to kind of assign it back, use the assignment back to a new object to kind of update it here. But here you just call fam.append and it updates the list itself, okay? It updates the list itself. So you can only append one item. All right, contrast that to doing here, basically I'm also gonna append something, okay? So here, let me just show you, okay, so this is what the list looks like here. And I can do fam plus list 1.8, all right? And then it looks like this thing gets tacked on here, okay? But here, this function here doesn't modify the value of fam, okay? Because if I ask what is fam, it doesn't include the 1.8 right there, okay? So it's just kind of like having a variable x, and then x is currently the value 10, and you say, hey, what's x plus 5? then it spits out 15, but X is still 10, okay? And that's basically what we have here, okay? We have the list fam, and I'm gonna say, hey, what's fam plus 1.8? It's gonna look like this, but what is fam? Fam is still here. If you wanted to actually change it, you would have to call this. You'd have to do fam plus 1.8, assign that back to fam, okay? And then now fam includes the 1.8 there, okay? Okay. Contrast that to just doing the dot append. The dot append actually changes it, okay? So dot append here, and one thing to kind of note is that when you call something like dot append, it doesn't necessarily output anything to the screen, okay? So when you see this and it runs, you might not recognize that a change has been made, okay? So if I were to run this cell again, it's going to append miles again to the thing, right? So if I keep running that, it's going to run into the thing. So, but it has been changed, and if if I keep running it, it's going to keep appending more and more and more to the list. Okay. When you do dot append, you can only append one object. Okay. So if I do fam dot append and I give it this list with 4 values in it, Miles 1.78, Joe 1.8, okay? That list of 4 gets appended as just one object or one entry, okay? So now if I ask what is fam here, now it's a list, and it, because it's not going to fit everything, it's a list where the first entry is Liz, the second entry is 1.73. Okay, the last entry is the string Miles, and then the last entry is this entire list, okay, of 4 items in it. Okay, so let me just kind of reset everything, and we're going to say here is the list, and then here I can kind of append, not append, but just I can concatenate a second list, and that will add the items individually. So I've got, the first list had 8 values, and then here we had 4 more values, so now we have a total of 12 values in this list, okay? But again, if you want to actually save this change, you have to store it back, okay? Because right now, as it is, fam just has 8 values in it, okay? 8 values. So if I want to store it, I got to store it back, okay? And again, you can kind of just call, times 2 on any of these things, and it will just kind of duplicate it, right? So here's 16 values in this list. We've got 8 up here, and then the same 8 kind of duplicated. So it's just fam times 2. So that's what we have. Okay, before I forget, let me give you your first view quiz answer, which is the letter B. B as in bear, B. Okay, list.copy creates what's known as a shallow copy, and so this, I want to kind of explain to you what is the difference between a shallow copy, and then if there's something called a shallow copy, then there's also something called a deep copy, okay? And a shallow copy will create a copy of the list, but if the list contains other objects, it doesn't copy those objects themselves. It just copies references to those objects, okay? Whereas a deep copy will copy the list and create copies of the objects that are referenced. So here I've got a list here containing A, 1, and 2. And we give this thing the name A, right? And then I have another list containing B, 3, and 4, and we give this thing the name B, okay? And then I'm going to create a list C, okay, which contains A and B, right? And so this A points to this thing, and this B is that thing, okay? And this we call C. So A is that list, B is this list, C contains objects A and B, which is that and that. All right, so here I'm going to create a copy of C, okay? And we're going to call this thing D. Okay, when I create a copy of C, it's going to contain object A and object B, okay? And these are the same kind of references to A and the same reference to B, okay? Whereas E is going to be a deep copy. And so E is going to be a deep copy. And now we're going to get kind of the entire object. It's going to look at what that thing is, and it's going to create an entirely new object here. Okay. So right now, when we ask what is D, it's going to look like that. And when I ask what is E, it's going to look like that. So they look the same right now. Okay, they look the same. Okay, but D contains just references to these objects. Okay, whereas E contains entirely new copies. So now what I can do is I could say, all right, just to kind of distinguish C and D, okay, I could say, hey, let's append X to C. Okay, so this is what C looks like. C now has X appended to it. Okay, so it's got the list A, the list B, and now X appended to it. Okay, I ask what is D? D looks the same. It's got the A12 and the B34. And what does E look like? It looks like that. Okay, but what I'm going to do now, okay, is I'm going to append a Z to A. I'm going to append a Z to A. So, so what are these things going to look like? Okay, when I print C, it will have A12Z, it will have the B, B34, and it will still have the X from earlier. Okay, when I ask what's D, D will have the A, A12Z, and it will have the B34, because these references A and B are pointing to these objects. And then E is entirely separate. It's not affected by any of those changes, okay? So if you understand what is happening basically in this code cell, as far as why C looks this way and D looks this way and why E looks that way, then you have an understanding of shallow copies versus deep copies here. Yeah, question.
In C++, we use pointers. Is this basically appended to that idea?
Yeah. This is kind of basically all of our naming in Python. Just basically points to objects in memory. So. Okay, and so if you ask what is A looks like this. A is A12Z. Okay. All right, so other methods that we can do with lists. One is we can insert an item at position X. Okay, the first insert the item at index position I, and the item that we're inserting is X. Okay, and so if you do a.insert 0x, that's going to kind of basically insert the value at the front of the list, okay? And then if you do a.insert and then you put in basically the length of the list, then it will basically be the same thing as appending it to the end, okay? So here I've got fam, Liz 173, Emma 168, mom this and that, okay? Joe 4 is going to insert it basically at the index 4 position, okay? And so the way you can think about this is you can count the commas, all right? So the comma, if I go 1, 2, 3, 4, it's going to insert it between 1.68 and mom, okay? And so you could see Joe getting inserted in between 1.68 and mom there, the 4, right? If you try to do insert, okay, so here I'm redefining fam, so I'm resetting the list, okay? And if I'm gonna insert, say, an object, this is a list with length 2, the entire object gets inserted in there, okay? So it's here I get 1.68, and then a list of length 2 gets inserted into that position, because lists can contain other lists or other objects, and so that's what we have there. Now, if you didn't want to do that, you might say, well, okay, I want it to be kind of like everything else. I want it to be 1.68, I want it to say Joe, I want it to be 2.0, and then I want it to say mom. And so if you try to insert more than one thing, like if you say insert into position 4, Joe and 2.0, okay, then Python says, no, you can't do that, all right? It says, I'm expecting only 2 arguments. One should be the position and one should be the object, and you gave me 3 things, okay? And so I don't know what to do, okay? So there's a couple things. One is extend. List.extend is basically going to kind of append things to the end, okay? So here I could extend it to say Joe and 2.0, and that will, and so here I'm providing a list of 2 things, basically an iterable with 2 things, and I'm going to append it at the end, and so that sticks on Joe and 2.0 over here, okay? But let's say you did want to have Joe, Emma 1.68, Joe 2.0, and mom, okay? If you want to do something like that, you can do assignment in conjunction with slicing, okay? But this time your slice is going to be 4:4, okay? So 4:4 is not actually selecting any elements. It's just kind of that 4th comma position, and then we're going to assign Joe and 2.0 into that spot, and so you can so you get it over here. Emma 1.68, Joe 2.0 goes into that 4:4 position, and then we still have mom 1.71, dad 1.89. Okay, so we have so anyway, all of this is possible, and we got it all in here. It's just yeah, there's a few different ways to do that. Okay, so that's list dot append and list dot insert. Okay, and notice all of these things. Here it says list dot insert and list dot extend or whatever, but basically you just take the name of that object. So if your list name is fam, we do fam dot insert, fam dot extend. Okay, if you have a different named list, then you use whatever name you have there. Okay, we have dot remove, dot pop, and dot clear. So dot remove just deletes whatever it is. Okay, so here, if I reset my list to have Liz 1.73 Emma, and I say dot remove Liz, it will remove that. Okay. So it'll remove the first item. So if you have Liz appear here multiple times, so if I have like, let me just kind of modify this over here. If I got Liz over here, it just removes the first instance of it, so you can still see this one still exists there. If it doesn't find it, okay, so if I say if my list has Liz here and then I say dot remove Lizzie, okay, it says that item wasn't in the list and you get an error. Okay. Here, okay, so this was an instance of 1.78, 1.71 just removes the first instance. So here I've got 1.71 appearing twice, and it just removes the first instance of it. Okay. Pop, okay. Pop will remove the last item in the list and return it. So you can assign the output of fam.pop to something, okay, whatever you popped here. So J will pop the 1.89, and we can ask what was the value that got popped. You can print out J, and then you can also print out what the list looks like here, right? So here when we took the list and we did fam.pop, that value is the value that got removed. So it's kind of like, on your computer and you do like cut, copy, and paste. If you cut it, right? If you cut something, it removes that thing, but it stores it somewhere. Okay, and so pop, removes the thing, but it stores it in memory, or at least somewhere. Okay, or I guess it gets returned, and you have the option to store it. Okay, you can specify the index. So you could say pop 0. Pop 0 will remove the index 0 position. So in this case, if I'm recreating the list fam, I'm going to do pop 0, and now we will remove Liz. Okay, and we can say J takes on the value Liz, and then again, fam contains everything else. Right? Dot clear clears everything out of the list. Okay, and so if you ask, hey, what is fam after we did dot clear, it empties it out. Okay, and you might be like, well, why would we want to do dot clear? Remember, lists in R are mutable, so you might have some reference, right, like A, to this, and so rather, like, if I later on, if I just said A, just create a new list that's empty, okay. The object here, okay, it's actually not A, it's actually referencing some memory address, okay? So the A here is not going to suddenly know that this A is empty, okay? It's still going to be pointing to this object in memory, right? It's going to have we no longer have a name for it, okay, because we stole the name A. We stole the name A and we used it here, okay? But now we've got, some mystery thing here, okay? And it's still this object, okay? So whatever object it is, that's still there, right? And so A is now an entirely new thing that points to an empty thing. But if you wanted to actually clear it out, you can do dot clear, right? And it will clear out the list. So the dot clear is still a useful thing, rather than just creating an entirely new object that has nothing in it. Okay, because if you just create a new object that has nothing in it, that's a new object. Whereas everything that has references to other objects, it's still referring to those things, even if it lost a name. Okay. List.index will return the index of the of whatever item in the list has that value. Okay, and if it doesn't find it, it will return an error. So here is my list fam, and I can say fam.index Emma, right? And it's going to count, so it's going to return the number 2. Okay, it's going to say, all right, this was the number 2, right? If I say fam.index 3, it's going to look for the number 3, and it's going to say, I cannot find it, okay? And so we get an error. It says 3 is not in the list, right? If you wanted the value at 3, what would you do? You'd do fam square bracket 3, and that will give you the value at index position 3, okay? So dot index will give you what is the index of, whatever this value is in there, okay? If you got multiple of the same thing, it's just going to give you the first instance. You can do a dot count. Dot count will tell you how many times does that thing appear in the list. So here I'm creating a new list of letters A, B, C, A, and A, and I can say do dot count A, okay? And it says, I see A show up there 3 times, okay? It's looking for kind of exact matches of the object and whatnot, okay? So here fam2 is a list of lists, okay? So Emma is a string inside one of the lists contained within the list fam2. So if I do fam.count Emma, it's going to say it shows up 0 times, okay? But if I say, hey, do you see this object list with Emma and 1.68 in there, then it says, yes, that appears once, okay? Okay, second answer is the letter C. C as in cat. C is your second answer. Okay, you have dot sort, dot reverse, okay? Dot sort will sort the items in place. So here is fam, and dot reverse will just kind of reverse the list of the elements of the list in place. So fam dot reverse. When you call fam dot reverse, it might not look like anything happened, but something did happen, okay? And so when you print it out, indeed it has changed, okay? If you call fam.sort, it's going to say, I don't know how to do this because we've got both strings and floats, and it doesn't know how to sort. You know, if I give you a list of numbers and words, and I tell you to sort them, you're not sure if the numbers should come before or after the words, okay? So if you just have all numbers and you can sort them, that's no problem, okay? So you can do sum digits dot sort, and it does it. Again, these things that modify things in place don't output anything to the screen. So if you want confirmation that something happened, you have to kind of print it out, okay? But sometimes you're like running a loop or running some code, a function, and you want these things to happen, but you don't necessarily need stuff output to the screen, okay? So by default, it's not going to output stuff to the screen, okay? But if you want to know, like, okay, what does the list look like after you did it? Sure, you can do that, all right? And it has no problems if you've got a mix of integers and floats. It has no problem sorting that, okay? It knows how to sort that, okay? Position 4 is still a float. That's no problem. You can do dot sort with reverse equal to true, and that will put it in descending order, okay? And then so when I print that out, indeed that's in descending order. Okay, here I'm creating a new list, okay? That dot sort is different from sorted, okay? So remember, dot sort, when you call it, it's not going to output anything to the screen unless you ask print the thing after you sorted, okay? But if you call sorted, it does print stuff out to the screen, and this doesn't modify, sorted does not modify the list, okay? So I think we talked about this on Monday, where I said you have two functions. You have list.sort, okay, and then you also have just sorted. And sorted will always output something. It returns a value, and so if you want to make use of it, you have to capture it, or when it returns it to the screen, okay. But you can see, you know, sum digits is left unaffected. Okay, so sorted gives you back a copy that has been sorted, okay, whereas list.sort will sort the list in place. So there is a distinction, and the use cases are similar but slightly different. Okay, strings in Python are treated as iterables, okay, much like a list, okay? So a list is, you know, you can put a whole bunch of objects, and strings are treated like lists in that they are they're sequences, okay? And you can do that. So you can say, all right, here is a string bananas, and then much like a list, you can subset, okay? And you can say, hey, what is at index position 0? Okay, that's going to give you the letter B. Okay, index position 1, the letter A. Okay. -1, okay, it will give you the last letter. If you try to put in something like a float, okay, it complains, right? So much like, kind of like subsetting a list, you could subset a string using square brackets. Length will tell you the length of the string or the length of the iterable or the object. So length of the list will tell you how many items are in the thing. As far as the string, the fruit here, the banana, there's 7 characters in it. So, or I'm sorry, bananas. There's 7 characters in it. So the length of fruit is going to be 7. Okay. Here I've got a string S, A, B, C, D, E, F, G, all the way, you know, X, Y, Z. So you can slice it. You can say string 4:9. What's that going to give us? Four is going to give me E, right? We're going to start with E, ending up at 9. So I don't know how to count. I think E through I. Okay. Okay. -6:. minus 6 colon will give me the last 6 letters in the alphabet. Okay, U, V, W, X, Y, Z. 0 colon 5 will give me the first 5 letters, A, B, C, D, E. And then here I can put it into a loop. So for X, so basically for each character in the first 5 letters, print X plus an exclamation point. And so we'll get, you know, A, B, C, D, E, you know, like we're cheering each of the letters in the alphabet, all right? One thing to note, though, unlike lists, strings are immutable. So once you create a string, you can't go and modify that string, okay? If you want to, so once a string object has been created in memory, that object is kind of set. It's permanent. If you want to change it, you have to create an entirely new string that either replaces that string or something else, okay? So if I wanted to change the first letter in the alphabet, so right now my string S is A, B, C, D, F, G, you know, up through X, Y, Z. If I wanted to change the index position 0 to a B, okay, it's going to say you're not allowed to do that. String object doesn't support item assignment. You can't take the index position 0 and then replace it. Okay, you can't replace that. Okay, but you know, you can kind of just create new strings. If you want to create a new string where the first character is a B and everything else, you know, you're taking all of the other letters, you can do that. But this creates an entirely new string. This is something different from the first string. Okay, we have a few methods that deal with strings. We've seen some of these. We have things like .upper, .capitalize, .title, .lower, and then so here I've got stats 21 Python and whatever. Okay, so upper is going to make everything uppercase. .capitalize capitalizes the first character, and then everything else is lower. Okay. Title is the first character after a space is capitalized. Now this is not. There's the style guides for English is that you don't capitalize. What is it? Conjunctions and prepositions and articles. Okay, I think. So Python doesn't know this. All right, it's not some grammar expert, and so you know it capitalizes the conjunction and the preposition for. And if there was the and a, it would capitalize those articles and stuff like that. Okay, so it doesn't know, but it just says, oh, here's a space. I'm going to capitalize the character that comes after the space. Okay, .lower makes everything lowercase, and then all of these things, again, these just give you back new copies, new strings that are modified versions of the original. The original string is left unchanged. Okay. All right, you can. Like, let's say you wanted to count how many times a character appears. So here's one way to do it. You could create a loop, all right? And then so I could say, hey, we're going to start off our count with 0. Go through each letter in the string name, and we're going to count how many times E appears. If the letter is E, add 1 to the count. I could have done count plus equals 1. Or I could just do count is equal to count plus 1, whatever. Print this out at the very end, and it says, okay, we see E appear 5 times in other, technologies, data science, right? So once in other, twice in technologies, twice in science. Okay, so it appears 5 times, all right? Remember, the list had the method .count. Strings also have this method .count. So we could say, hey, .count E, and it finds that, okay? You can also do things like, IE. So IE appears once in technologies and once in data science, things like that, okay? I don't know, RSpace, okay? RSpace other and for, okay, but anyway. So you can just kind of search for all of these things, .count, okay? It is, so index searches for the character and gives you the index position of the first match. So we can say, hey, find a capital A and give me the index of where you find capital A for the first time. So as far as stats 21, this is the thing, so it finds it at index position 2. Okay, and if you give it something that doesn't exist, like capital E, it says, I couldn't find it. I couldn't find it. Okay, at least not in the original name. But if I did it in name.upper, oops. Okay, so name.upper, now it looks like this, and then, is that, index position 23, is that right? I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, okay, yeah, I guess 21. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's try the capital P. It's easier for me to read. Okay, yeah. Index position 9. Yeah. So you can do that. But again, all of these things are kind of, so if you look for capital P in the original name, it's not there. But if you do name.upper, then it will be there. Okay, so that's fine. Ends with K is going to return a true or false value. Okay, does the thing end with a K? It does not, so that gives me false. Does it end with an E? That is true. Okay, does it start with an S? Does it start with a lowercase s? That's false. Okay, things like that. If you want a string that spans multiple lines, you can do that as well. You can do triple quotes. Triple quotes will let Python know that, hey, this string is going to span multiple lines. And it's in there, okay? Dot strip will take any kind of string and remove extra white space, leading and trailing white space. So here, white spaces includes new line characters and spaces and tabs and things like that. So, so we have that. Strings themselves are immutable, so even though I strip the white space, okay, this is a new string. This is separate from the original string. So name2 is still unchanged, and it looks like this, okay? Python treats printing a string, so if I print name2 versus just if I ask what is name2, what is that string there, it treats it a little bit different. So name2, it shows that this is a string. It surrounds it in, kind of the quote marks, and then it shows the new line characters as /n, versus printing it, prints it out to the screen in the form that it appears there. Okay. Okay, we have string.split. String.split will take whatever string it is, and it will split it at the white space by default. Okay, so here it splits between Miles and Chen, and it returns a list of the different strings after splitting at the white space. Okay, you can provide another character to split on. So here I've got a string with numbers and commas, 2, 3, 4, 7, 8. And if I call string.split, it defaults to looking for white space. It doesn't see any white space, so it's not going to split anything. But I can say, take that string and split it on the comma, and then it will return a list where everything's been split up. So here is just a list where it just contains one string of that. And now I've got a list with 5 things, and it's got 5 strings with 2, 3, 4, 7, and 8. Okay. Now, if you wanted to do, say, math with this, you wouldn't be able to because these are strings. It's the string 2, it's the character 3, character 4, and so you can do something called the list comprehension, where basically we can take each element and throw it into the function int, and that will kind of convert a string into an integer, right? So if it can. So here I'm going to do numeric string.split on the comma, and then we're going to just take each of those x elements and then turn them into an integer, right? And so now I've got a list of integers, 2, 3, 4, 7, and 8, okay? This is called the list comprehension. We'll cover that in actually a few weeks, so it's coming later in the future. But you could also do it this way. You can start off with an empty list, and then you can say, hey, split the string, okay, all right, based on the commas, and so that's going to create this this list of strings here, and then we're going to go through each element in there, and then turn that into an integer, and then append it to L. And when I do that, I get the same result. Okay. All right, we have a few kind of is statements. All right, and these are going to check to see if the string meets certain criteria. So is alpha is going to check to see if it contains only alphabet characters. So that's the capital letters A through Z and the lowercase letters A through C. So because the name string has numbers, digits in it, and spaces, it's not going to qualify as is alpha. Okay, so we get a false there. Okay, but if I have a string that's A B B A Z and stuff, that one is alpha. Okay, but if I put in the digit 4 here and I say, hey, is this thing alpha? That's going to come back false. Okay, so is alpha is looking just for the letters, alphabet letters. Okay. Okay, here is some quotes from a song, and we can turn everything uppercase if we wanted to. Okay. You can split. Split will split at the spaces, and so that creates a list of all of these words. And you'll notice the commas get put in, okay, into the words there and stuff like that. Okay. Split lines will split at new line characters. Okay. So here now I have a list, one with each line. Okay. And you can still kind of go through and you can count, even if it's a long string, you can still count like how many times the character E appears. It appears 15 times there. Okay. We could ask something like, I want to search for the thing. Okay. So here's a function that will go through and kind of count or search for a letter and return where it finds the letter. Okay. And so we can say, hey, search for the letter T. Lyrics to the song Hallelujah. It's going to find the letter T at index position 7. Okay. We have dot find. Okay. Dot find T will also give me back a 7. I can do dot index T, and that also gives me back a 7. So you go, hey, well, what's the difference? Why do we have a dot index and a dot find? Okay. The difference here is that the way it handles not finding a letter or not finding a character is different. Okay. If you search for something that doesn't exist, so if I say, hey, search for the character $, okay, when you do dot find, it's going to put back a -1. When dot find returns a -1, it means I couldn't find that character in the thing. Okay. What happens when you do dot index? Dot index returns an error if it can't find it. Okay. So the way it handles not finding the character is different between dot find and dot index. Sometimes you want the error. You want your code to stop running because maybe you actually need the that thing to actually exist. Okay. And other times you don't want it to crash your code, and you just kind of want it to do something else. So in that case, maybe dot find is better. So knowing which one's going to return an error and which one's going to kind of go on, that's what we have. Okay. The in operator is will return a true or false, basically, if that substring exists. So does the character A exist in bananas? Yes. Does the sequence NaN appear in bananas? Yes. Does the sequence BAD appear in bananas? No. Okay. So we get a false there. You can use greater than and less than, and again, this is kind of like, does one come before the other in the alphabet? Okay, all capital letters come before all lowercase letters. So A comes before B, lowercase a comes before lowercase b, but capital Z comes before lowercase a. Okay, digits come before the capital letters. And this is a little bit strange, but when you're alphabetizing things, okay, like A would come before AA, and 0 comes before 0, 0, okay? And then also, all right, like AA would come after, okay, so if we say this is like BB, and this is BAB, okay, 1, 1 alphabetically comes after 1, 0, 1 alphabetically. Even though numerically 11 is smaller than 101, this is not numeric. This is characters. So the character 1, 1 comes after the character sequence 1, 0, 1 because it's like BB coming after BAB. But numerically, that doesn't make sense, right? But this is stuff that happens, right? Okay. The keyboard characters is like, it feels very arbitrary. It's based on the ASCII table. And so you can kind of say like, okay, sort all of these things. And it says, I don't like syntax warning. Okay, it doesn't like this, the backslash here. Okay, so if I get rid of that, this is how it sorts the characters, okay? And again, it feels very kind of arbitrary, but it's based on the ASCII table, which is, kind of the old, all right, that's too hard to read. Okay, we'll go to the Wikipedia entry. So this is kind of like, one was ASCII developed, 1963, okay? So that's what, 60 years ago? Oh, 61 years, and we must have missed the 60th anniversary of ASCII. But that's kind of how we standardize things, and this was kind of coming from like a time where people used the telephone, and so you had like these weird line feed characters and stuff. But anyway, that's that. Okay, we'll wrap things up here. I'll go ahead and give everybody the last view quiz answer. Last view quiz answer is A as in apple. A as in apple. So those of you watching the video, you also get the last view quiz answer. And we'll end there. Have a great weekend, and we'll see you next week.